All right. Well, welcome everybody to today's open science meeting. Hope everybody is staying cool, except for Lindsay, who is probably enjoying the summer. Um, all right. So, just going to start with the agenda. We'll do some welcome and introduction since, like Marcus said, I see some new names too. So I'll just go through the list that I have here, and I'll just read off the names, and we can if you can just say your name and who you're with, that'd be great. So I'll start. I'm Alex Manos. I'm with Pinellas County Environmental Management, and I am the co-chair of the Open Science Subcommittee. Marcus.
Good morning, everybody. I'm Marcus Beck, Senior Scientist at the Tampa Bay Estuary Program. I am the second co-chair of this Open Science Subcommittee.
Thanks. Cheryl.
Hello, I'm Cheryl Clark. I'm the Senior Program Analyst with the Florida Department of Environmental Protection.
Lindsay.
Hi, Lindsay Platt. I'm an environmental data scientist with Quasi. I'll define that acronym later.
Dave.
Hi, Dave Carlin with the Environmental Protection Commission of Hillsborough County.
Tyler.
Good morning. I'm an environmental specialist 3 at DEP working on the CCAR team.
Stephen.
Hey, good morning. I'm Steve Durham. I am also an environmental specialist at DEP working with Cheryl on the CCAR team.
Mila or Mila.
You were right the first time. Hi, I'm Mila. I'm an environmental program coordinator in Pasco County.
Elise.
Hi everyone, I'm Elise Morrison. I'm an assistant professor at the University of Florida in the Environmental Engineering Sciences Department.
Kimberly.
Sorry, I said I would speak up for Kimmy. Kimberly is with Quasi. She's in California though, so it's very early. So I was gonna say hi for her. She's just joining to listen to some of these talks. She's an environmental data scientist fellow with us.
All right. Cool. Lauren.
Hi, I'm Lauren Mulligan. I'm with Manatee County Natural Resources.
I see Jay Mick.
Hi, Jonah Mick with Pasco County Environmental Division Director.
Jordan.
Hello, I'm Jordan Bentley with RES, and I'm a Scientist 3 on our water quality team.
All right. Well, good to see everybody, and thanks again for coming. See the agenda here, so we'll just go straight into it. So first thing we have up are the open science updates by TBEP and partners, and this is Marcus, so take it away, Marcus.
Thanks, Alex. Do you have any updates before I jump into mine?
I do not have any updates right now.
Okay. Busy with field work.
Yeah.
Okay. Right. So we have a good line of speakers today, so I will try to keep my portion brief as always, but since we've been doing these meetings every 6 months, this is the first one of the year. And within those 6 month chunks, I usually have a whole slew of updates to provide to you all that I'll go over. It's primarily informational, but hopefully it's things that you find interesting and useful. Feel free to interrupt me as I go through them if you have questions or comments about any of them. These are things that I find useful that hopefully I'm assuming you all find useful, but let me know if any of this is good for y'all. Okay, so yes, we do have I always start with this one. We do have a a roles and responsibilities document that outlines what this group is all about. But I know many of you have been here before, but since there are some new faces, I'll just briefly talk about what it is. This is a subcommittee within our technical advisory committee, which is part of our larger management conference as the Estuary program. And it's good to define what we do. And so you can look in this guiding document to see these things in details. But basically, the three things we try to do is more or less develop a community of practice around open science within our region. So we support development of open science products at the Estuary program as they can help you all as our partners. Um, we also try to identify priority research areas for developing products, and actually some of the things I'm talking about today speak to some of those priority areas. When I started here 6, 7 years ago, there were some indicators and products already available, but as I progress in my career here at the Estuary program, there are new things that we need to think about where we know data exists, but not necessarily workflows for synthesizing that information. And so I kind of look to you all from time to time to sort of prioritize what those items are that we focus on. And then lastly, we try to facilitate training activities, which we haven't done in a while. I know Alex, you're doing an R training at the FLIMS meeting later this year. So if you're going to that, it's the Florida Lake Management Society. You can catch him, and I forget the other individual that you're teaching with, but I know you've done those trainings in the past, and they have been well received. I'm doing an R training for SwiftMud next month. That is just for SwiftMud, but that content will be available online for anybody to access after the training. And I can share that link later if you're interested. But we still do these training activities mostly are focused, but we've done more general open science trainings in the past. And if there's an interest or need within your organization for those types of trainings, just reach out to us and we can help you set that up. Okay, first update is our new dashboard. This has actually been online for a couple months now, but in prior open science meetings, we've hinted at the fact that this was coming and will be made available soon. This is coming out of our hackathon that we had January of 2025, where we contracted with, it was a competitive hackathon where folks were working to, if you were selected out of the hackathon, you were invited to contract with us to sort of fully develop the proof of concept that was developed during the hackathon. And the group that we ended up working with was a contractor, Drummond Carpenter. I think they're based out of Orlando area, but they have some remote folks kind of all around the state. And they developed proof of concept around an invasive species dashboard, which was a situation where we know we have data available. It just was sort of disparate and not really synthesized in a way that was useful to practitioners. And we've vetted some of the concepts to, I think, this group, but also our TAC when we were initially developing this. But we're still kind of thinking about how this information can be used to prioritize management actions. And it's still a work in progress, but the working product is available online. You can access it here. It's a Python-based dashboard, and it pulls in primarily a USGS data set that is sourced from a lot of different locations, but I think the bulk of the data comes from iNaturalist. So USGS is tapping into iNaturalist data, which for all its bumps and warts, it is a good indicator source for invasive species because it leverages the crowd to get that information. And they've also what they've done is they've overlaid the all these points are going to be different observations for the entire period of record of different groups, amphibians, fish, mammals, mollusks, plants, reptiles. They've overlaid this on top of this layer right here, which is FLAM, which is the Florida Lands. I forget what that stands for, but it's a layer that sort of um, identifies the ecological integrity or value of the landscape. And the idea is that by intersecting where we see these sort of non-native species with high quality habitat, you might want to prioritize places that are, at risk of invasion or otherwise stressed by invasive species. And so that's where you see these high priority hex bins that you can toggle off and on and choose which ones you want to see. The other addition here is we did integrate the FWC FIM data into this, so fisheries data. The USGS data set is mostly going to be land-based observations, and we know that aquatic invasive species is another big part of the puzzle. So we integrated FWC's fisheries independent monitoring data into this, and that's what you can see all these. I think a majority of these points are like um, Mayan cichlids, basically in the Hillsborough River. But that was another piece where before we rolled out the dashboard into production, we wanted to integrate that other data source to complement the USGS data set that was in there. So that's available. We're open to ideas on how this could be used to support management. This now it's in sort of a synthesized place where you can see it. Ideally, we want these things to support action at some level. So let us know if you have any ideas about that. The next update, and I see Dave Carlin on the line from EPC. The Estuary program, in partnership with EPC, with Hillsborough County, we support the benthic monitoring program for Tampa Bay. And for years, EPC has been collecting benthic samples in the bay, looking at sediment health, as well as the critters that live in the sediments in response to those contaminants in the sediment. And there's a whole slew of products that come out of that. Dave has produced these wonderful synthesis reports looking at, the entire data set, 25 years. And I think the most recent one was a 30-year synthesis of that. But for the open science products, we have a couple different things. We have a benthic dashboard that showed, the contaminants in the sediments, as well as a Tampa Bay benthic index, which is a biotic index looking at the health of the organisms in the sediment. And there's also been a parallel index that we never really synthesized into our open science products. And through the help of EPC, that's something that I finally ported over to sort of open source tools and integrated into our existing open science products. And that is called the AZTI Marine Biotic Index. This is another index that complements the Tampa Bay Benthic Index as another line of evidence looking at the health of the organisms in the sediment. Unlike the Tampa Bay Benthic Index, the AMBI is something that is used around the globe. I think it was traditionally developed for looking at coastal areas, harbors that are really impacted by legacy contaminants. So what it requires is adapting it to local conditions, because it uses a species lookup table where each species is assigned a tolerance value, and those tolerance values vary regionally. And so that's where a lot of the heavy lifting came in when this was adapted to Tampa Bay. And so that was all available. It was in the synthesis reports that EPC produced, but now we have this at the Estuary program as part of our routine reporting products. And so this is what this table is showing you is just sort of a breakdown. It categorizes individual sites that can then be scaled up to the bay segment level and groups them into different tolerance classes that can be mapped to degrees of pollution in the sediments. And so this is a breakdown of all of the stations by the bay segments and the percentage of sites that fall into different categories here. This is all documented in our package, TBEP tools. This particular vignette talks mostly about the Tampa Bay Benthic Index, but you can read about the AMBI here and how it's calculated. using some of these R-based tools, some of the reporting products that come out of it, report cards, time series of the scores, and then that breakdown of proportion of sites by each bay segment that I just showed. What's kind of interesting about this is unlike the benthic index, where we see a much more larger spread of scores throughout the bay in terms of these categorical descriptions, the AMBI shows most of the bay as being what's called unpolluted or slightly polluted, those two highest classes. And um, that when we saw that, we were kind of like, well, it's kind of not particularly useful when you're using an index to prioritize projects looking at sediment health. And we did have discussions with EPC about what this means and how we might improve on it. But there's two kind of ways to look at it. One is that, compared to other locations around the country, the world, sediment health in Tampa Bay is maybe pretty good because the AMBI was really designed to assess heavily degraded locations. So that's one perspective to look at it, one way to look at it. The second way is, maybe these breakpoints for defining these categories could be modified, perhaps to make it a little more sensitive to the range of tolerances we see in Tampa Bay. And so that's something we've talked about that maybe we might bring to our technical advisory committee for how to improve this index. But the point I want to make is that it is, an alternative line of evidence for looking at sediment health. And so I did do some initial analyses, and I know Dave and other EPC folks have done this as well, but I was just looking at sort of concordance between the Tampa Bay benthic index here by the bay segments over time, and then the AMBI here. And you can see that they do, if you sort of squint your eyes, you can see that they do kind of track each other pretty well. But there are times when one index provides different information than the other, and that's when there's value in using two different approaches to assess environmental condition, because they should generally complement each other but provide slightly different information. And so I was diving into those instances when the two indices sort of diverged to see why that was, and was it a product of the index itself, or something going on in the environment that was demonstrated differently by the two different approaches. So we're still actively looking at this, but this was a new addition to our workflows that, again, provides another line of evidence looking at sediment health. Yeah, Stephen.
Hey, I was curious if you were also going to look at the multivariate version of AMBI. We just were looking at this in CCAR as well, and the multivariate AMBI seems to be much more sensitive than the traditional AMBI in our explorations of them.
Yeah, Dave can probably speak to this better
Yeah.
than I can. Yeah, go ahead, Dave.
Yeah, we haven't yet, but that's something I do want to look into. I haven't really delved too much into the multi the AMBI yet, too. But
Yeah,
Okay.
so the version that we have here,
a better
there's
tool as well.
Yeah.
All right. Yeah, I was just curious if we can be of any help. Let me know. I can share the report that we did, and if that would be helpful to you at all.
Oh, that actually would be. Yeah, thank you.
Mm-hmm.
Yeah, and just some more background. There's two variants of the AMBI that have been applied to Tampa Bay. There's a GOM, Gulf of Mexico AMBI, that was developed by David Gillette and colleagues a couple years ago, that can be applied to Tampa Bay, but that one was not as sensitive, and so that was the whole motivation for developing a Tampa Bay specific AMBI, which basically just requires assigning regionally specific tolerance values to each species, and then that funnels up to the AMBI score. But yeah, Stephen, I appreciate that. If there's ways to improve on this, we should definitely connect later.
And Marcus, you said there were some changes when you did the regional assignments. Those were in Dave's report. I'd be interested in seeing the differences because we used um, some different assignments that were done by the Gulf Breeze office,
Hmm.
Jenny Paul, but we didn't. I didn't see the differences in the Tampa Bay version, so I'll check that out.
Yeah, there's a table somewhere buried that I could probably send you. It's available. Yeah.
Awesome.
Yeah, yeah. We developed our own list for Tampa Bay, which was a little different than what was developed for the Gulf of Mexico. Kind of based on on our data set as far as sediment contaminants and dissolved oxygen and what organisms are found in different types of habitats, and kind of assigning them tolerance levels based on that. So it was a little
That
more specific for our data set.
that's awesome. I'll definitely check that out.
Yeah, shoot me and Dave an email after this if we forget to connect with you. Okay, the last thing I want to mention, I don't know if anybody on this call was part of our seagrass training last week, last Thursday. But as many of you probably know, the Estuary program coordinates the interagency seagrass transect monitoring program, which is our annual effort where about a dozen partners, maybe a little bit less than a dozen, go out around the bay and survey about 60 something transects for seagrass. And that's been going on since the late 90s. And each year we hold this training right off the north side of the Skyway Bridge, where all the people that go out and collect these transects meet in one place and sample each of the quadrats to make sure that we're all using the same methods, we all get similar results. And that's been going on for a number of years. But last year or the year before, I was working on developing a report card to share with each one of the partners that go out and do this training to sort of sh not to put anybody on blast, but really just kind of show them where they're doing good, where they could use improvement, as a means to really make that training a little more sort of close the loop with how it can actually support efforts of all of us doing the same thing when we're going out and getting these surveys. So I created these report cards last year, but since we had the training last week, I updated a lot of it. I've improved some of the scoring methods, made it a little more robust, and actually have a better landing page for it. And if you go to this link, you can kind of see we started this training, I guess, back in 2020, or at least that's how far back I have data. But you can go to, if you're part of this group, I don't have this year's data from last week up there yet. This should be up in the next week or so, but you can go to your scorecard in in a given year for your group and see how you performed. I've also got a multi-year dashboard to see how scores have changed over time. And I have been toying with the idea of, writing this up to sort of evaluate the effectiveness of this program as a whole, using these report cards as a vehicle to describe the success or um, ways we could improve this intercalibration training. So if you're part of this effort, definitely have a look at this. Let us know if you did the training on Thursday. We will probably send out your individual groups report card probably next week or shortly after that to give you some feedback. But this is something we totally concocted internally, and we want feedback from the broader group on how this looks. What also is in addition for this year is this much more detailed document that describes how the scoring works, probably in way more detail than you care about. But it's kind of hard when you don't know what the true value is at any given site that you're looking at. So we kind of go off this like consensus based approach of how far does your evaluation vary from like the group mean overall as the basis for seeing how well or how you could improve your scores. So that's the general idea. There's some other improvements in there, but hopefully that improves transparency about how we're doing this, and in the end will improve how we're all kind of working together to do this seagrass training. And happy to share this information with anybody that has more questions. Yeah, there's a screenshot of the dashboard. EPC is just killing it over the last couple of years. And yeah, so that's all I got for updates. Towards the end, yeah, I'm coming up on 10:30, so I'll stop there. But I always have some links in here that describe some cool things I've seen since last time we met. And if we have time towards the end, I'll talk about some of them. But yeah, at this point, I'll turn it over to our speakers. I want to give them plenty of time to talk. Um, let's see, where's our agenda? See, Cheryl, I've got you first, but I didn't really talk with Lindsay or you about order on this. So if you know, if Cheryl, you want to go second, Lindsay first, whatever, doesn't matter, but
I have
usually
no
people are
problem
pretty
going
cool about
first. I looked
Okay.
at the agenda, so I anticipated it.
Okay, well then I'll stop sharing my screen and I'll let you take it away.
Okay, I'm gonna attempt to share my screen before.
And just some background, I've been loosely associated with Cheryl's group over the last couple of years. I've gone to their tech trainings and given some of my perspective on open science and some of the things we do at the Estuary program, and I've just been really impressed to see this program grow over the years. And so I was talking with them a couple months ago at their last tech transfer. I invited them to come share what they've been doing to our open science subcommittee. Kind of to phone in a favor because I've traveled to talk to them, but I said, Cheryl, come talk with us. But nonetheless, I think CCAR is great, and the Aquatic Preserve Program is great, and I wanted to give Cheryl a chance to talk with our group about it. So that's all I'll say.
Well, thank you. And Marcus is downplaying the amount that he has contributed to our programs. I'm trying to get this Zoom thing to not overlap with my controls so I can actually change the slide. But yes, I want to thank Marcus first for inviting us to speak today, but also for allowing me to pull him into our projects on multiple occasions to pick his brain and utilize his talents to improve the work we're doing. One of the projects I pulled him in on it was not written this way in our agreement, but basically to do our script for dummies version. We had a contractor who didn't provide all of their work in a very usable format, and he translated all of that for me. So that was invaluable to me. But I also want to acknowledge Dr. Stephen Durham and Tyler Hill, who are on this call and are part of the CCAR team, as well as Dr. Sean Landry and Claude Kershaw with the University of South Florida, who are an integral part of our team. I started my career with DEP working in Estero Bay and kind of living out my dream of working in the field and collecting data. But most of the data that I was collecting and that had been collected in the past was just sitting on computers because we didn't have the resources to do anything with it. And many of the protocols didn't align with the larger programs. So I started looking at ways to address these issues. And that led to being offered the opportunity to move to Tallahassee and lead this statewide effort. And that's kind of the story I'm going to tell you today. This project and all of the projects that I'm going to talk about today were funded by NOAA's Coastal Zone Management Program and the Florida Department of Environmental Protection. So DEP's Office of Resilience and Coastal Protection manages 43 aquatic preserves across the state, and this network of submerged lands and associated waters were designated for their aesthetic, biological, and scientific value and set aside to be maintained in their essentially natural or existing condition under Florida's Aquatic Preserve Act of 1975. These areas are also afforded the state's highest level of water quality protection as outstanding Florida waters, ensuring that no degradation of water quality is permitted. And one of the critical tasks of the aquatic preserve staff is to monitor water quality in support of maintaining these statutory standards. So across the 41 marine and estuarine aquatic preserves, AP staff have collected over 400 million discrete water quality monitoring records and well over 60 million continuous water quality monitoring records. And while these numbers are impressive, no single organization can comprehensively monitor water quality across 2 million acres. So instead, the monitoring and management of water quality in Florida relies on the partnerships among a large number of organizations, including local, state, federal, NGO, and academic institutions, all working together to preserve and manage Florida's natural resources. And if we can work together in collaboration, sharing knowledge, and leveraging our resources, coordinating efforts, we can save time and money and improve data sharing to ensure that Florida's most valuable resources are preserved for future generations. But this is difficult because historically, as I said, there's differences between organizational missions. We have limited resources, and this has led to disparate data sets, which were inaccessible or being underutilized or not utilized at all. And then on top of that, as we all know, data is not information. So despite how much data we collect, if we're not sharing and translating that in a meaningful way, it can't be used to accomplish the goals of preserving and protecting Florida's resources. However, the numerous challenges can make generating information from a combination of multiple data sets very laborious, and data can be very hard to find. It's not always clear how data were collected or how they relate to data sets collected by others. And it's not always easy to build on those types of analyses to generate new information at different scales or for different indicators, because every new data set that you bring in can result in some of the same challenges over and over again. And the longer it takes to process the data and generate information needed to inform management and restoration. So the statewide ecosystem assessment of coastal and aquatic resources was initiated to address some of these challenges. Through an intensive stakeholder-driven collaborative process that included participation from over 80 organizations and 180 individuals just during the initial meetings alone, CCAR was developed. There were 5 priority habitats that were identified, and that included water column, which encompasses water clarity, water quality, and nutrients. Additionally, the stakeholders outlined the criteria for creating a statewide centralized database to house all of the data in one place to provide consistent, well-documented data for multiple habitats. In addition to the stakeholder feedback, the development of this database has been inspired by published guiding principles for data management and repository design, including FAIR and TRUST, respectively, and resulted in a resource that addresses a broad set of user needs and reduces the time and effort required to conduct meta-analysis of multiple programs' data. The CCAR database and analyses products together ensure that data are clearly and explicitly linked with detailed metadata and are indexed in a searchable resource, provide access to large and diverse data sets and metadata in a format that's easily retrievable, free, and universally implementable, integrates data from different organizations and maintaining transparency in the data's origins and handling, and that includes both by the CCAR team and the originating programs, and provides an infrastructure and capabilities to support secure, persistent, and reliable services for data storage, retrieval, and analysis, translating millions of data records into usable information that can be replicated, shared, and used to inform management, restoration, and policy. The data discovery interface was created in collaboration with the University of South Florida Water Institute as a public data portal to the CCAR database. It was designed to allow for easy transfer to any Microsoft SQL and ISS servers. And the DDI was, or has dramatically increased the visibility and findability of the data, including water quality data that's collected by the aquatic preserve programs and partner agencies. Many of these data sets previously were only available upon request, and sometimes the discrete samples were entered into water quality specific databases like EPA, WQX, and WIN. But for those of you who have tried to access those, the information is generally under organizational codes that are not easily interpreted by most people, and they vary in formats. The data providers have password protected access to edit their program pages and upload data, spatial data reports, and accompanying documents through a drag and drop system with no reformatting or duplication of efforts. The program's raw data files are ingested in their original format and then standardized by the CCAR project team. So data users have access to both the program-specific raw data files and the standardized CCAR data files that can be easily combined to facilitate meta-analyses. And although we ask programs to only submit quality check data, CCAR does provide an extra layer of QA/QC through the program editor dashboard, as well as through the data integration process that's developed for each program. There's multiple feedback loops throughout this process. The CCAR team receives an email every time a program page is edited, and we review the information and either move it to the next step or work with the data provider to address any issues. The data providers and the public can easily report any issues that are seen from each of the DDI pages. Programs are also asked to provide associated documentation for their raw data sets, and these files are available to users to download in commonly used machine-readable formats, such as CSV and delimited text files. The program contacts are listed for every program, increasing transparency as well as recognition for the data collectors. And detailed metadata files are included with every download and available on the program page. The metadata files include 26 worksheets and project team used for defining the parameters, land cover. And summary information about each program is available, and data is easily visible on each program page, along with the spatial distribution of the data, which can be viewed on the mapping pages. Because all of the data is publicly available, having data in the CCAR DDI has helped many of the programs meet funding requirements and also aids in public records requests for our staff. So we designed the DDI with a focus on accessibility, and all of the programs contributing data to CCAR can be accessed through the program matrix page. We designed this page to include the pertinent information from each of the program's individual pages, allowing you to assess the comparability of the programs. And programs can be searched and filtered to meet specific criteria. You can export your search results, and if you choose the Excel option, the program name is hyperlinked back to their CCAR program page, so you can continually check back and find updated files. Each program is standardized and includes summary information, contacts, links to raw and standardized data files, data integration procedures, and the CCAR export file metadata documents are available. And each page has a program extent map, which links to the sample location map. The mapping features utilize Estuary mapping products and allow users to view data using CCAR's multi-habitat approach, providing a unique opportunity to view data in different habitats by different data providers all in one location. You can view the spatial extent of monitoring across Florida, and this map shows the seagrass monitoring locations, and different sampling methodologies are depicted by different colors. The CCAR mapping feature also allows you to zoom into areas of interest. And if you want to learn more about any of the programs or locations depicted, you can select a location and a pop-up will provide detailed information. And again, this links you back to their full program page. But we all know that the health of our seagrass is dependent on water quality and the health of those parameters. So you can overlay benthic data with water quality data, or in this case, turbidity data collected by different organizations. And all of this data is available through the CCAR DDI and is available for analysis and can be explored through a number of publicly accessible dashboards and reports for both technical and non-technical audiences. The CCAR meta-analyses are being used to create reports, dashboards, monitoring planning tools, and more, which we're updating regularly, usually quarterly. And links to these products, the R scripts, the raw statistical outputs, and summaries of the data and model results are all available on the Florida CCAR GitHub site. The CCAR Habitat dashboard allows users to interact with data at the managed area or program level. And here we're looking at Pinellas County Aquatic Preserve, and you can link to the figures and plots, including seagrass cover and water clarity analyses, which utilizes the same data that we were just looking at in the CCAR DDI map. And so while we want the raw formats to be available on GitHub, we acknowledge that GitHub can be difficult to navigate. So Tyler developed the GitHub splash page for us, in addition to these other resources, to provide easier access to the various CCAR products, including the dashboards that I just showed you, monitoring planning tools, and reports. And we plan to further expand these products based on additional stakeholder feedback. So because CCAR was funded through the Coastal Zone Management Act under the Section 309, we were eligible to pursue Project of Special Merit funding for projects that would augment CCAR. And our first PSM was the integration of Florida's Aquatic Preserve continuous water quality monitoring data. This project was funded through NOAA in 2017, and the project really exemplifies some of the same challenges that we just discussed, but all within a single program. And its solutions mirrored those that we had implemented through the broader CCAR project. The aquatic preserves maintain a network of continuous water quality monitoring stations around the state. But historically, these data were only housed locally and underwent little to no QA/QC because they were being maintained. Because they were not being maintained in a consistent format. They weren't accessible and they were being underutilized. So in collaboration with the Centralized Data Management Office, we created a monitoring program that aligned the aquatic preserves with the National Estuary Research Reserve system-wide monitoring program, which has 16 stations in Florida and 299 stations across the country. And mirroring their program, we established standardized protocols and data handling procedures, quality assurance documents, and training modules, which is what Marcus was just referring to. He had attended this year's annual training. And the pre-existing data underwent evaluation and analysis, and this included the QA/QC of over 4.25 million data readings that were dating back to 2003 when the program started. Reports and assessments were developed, and an online portal was created to make the data publicly available. And due to the success of this initial effort, the project was awarded a 1 DEP Living Our Values Award in 2019, and this provided us the support and resources, including recurring state funding, to expand this program, which has grown from 16 active monitoring locations in 2017 to 29 active monitoring locations now, and also includes an equipment maintenance program to ensure that we're collecting the best data possible. And they said they didn't want to be included on the slides, but I do need to thank Dr. Dwayne Porter, Melissa Ide, and Jeremy Cothran for their contributions and support to this program. So the Florida AP Data Portal is a Python-based site which provides program information for all of the aquatic preserve stations, including metadata documentation, graphing features, dashboards, analyses, and custom download applications. The graphing features allow you to select any of the 53 stations, including active and historical sites, and select parameters and date ranges to plot and download. The portal currently houses over 11 million data records for 7 parameters. The AP Data Portal dashboards include a dissolved oxygen analysis based on Florida's surface water criteria for dissolved oxygen in marine waters, and identifies 1-day, 7-day, and 30-day events for each year and station. And the station statistics are provided for percentile classes at both the weekly and annual timeframe. Aligning the aquatic preserve continuous water quality program with the NERS Swamp program also allowed us to utilize existing open source scripts to analyze and present data, and that included a series of Shiny apps created by Marcus and Todd Oberon. And again, Marcus graciously worked with Jeremy, and they converted the scripts from R to Python so that Jeremy could use them in R. So once the AP data was brought back into CCAR and combined with other continuous water quality efforts, you're able to see the broader statewide picture. And once, so you can see, oops, there we go. You can see the active and historical sites, and you can select specific managing entities such as the Aquatic Preserve Continuous Water Quality Monitoring Program. You can review individual programs and stations, as well as parameters collected and the number of years of data. And the trend analysis results are also provided for locations that have more than 5 years of data. So utilizing the standardized data has allowed us to look at ways to optimize our monitoring programs and resources. In Biscayne Bay Aquatic Preserve, we were able to identify redundancies in data collection between sampling locations for both continuous and discrete water quality, and create a measure of how similar the data being recorded is to the data recorded by nearby stations. And this allowed the aquatic preserve manager and the department leadership to reduce the number of monitoring stations managed by the department, saving time and money and reducing the duplication of efforts with other organizations. So after conducting the water quality optimization analysis, we wanted to look at ways to expand this concept statewide. The water quality optimization dashboard is now being piloted in Charlotte Harbor and allows you to visually explore the results of the optimization analyses, compare variability and similarities between stations, and the sensitivity analyses quantifies the impact that a given station has on the overall long-term trends in the region for each parameter. So the integration and evolution of Florida's aquatic preserve data has been an amazing project to be part of. Both the CCAR and the aquatic preserve programs are working to make the data more useful and accessible to a diverse audience, which includes general public, scientists, and agency decision makers. And we're working to improve the clarity of our communication as well by catering the information for multiple audiences at different levels of expertise. We're creating several story maps and an atlas website for a more general audience, which highlights the CCAR analyses hopefully in a more accessible context, including detailed explanatory text and captions for the figures, and summary analysis for indicators that include multiple parameters. We'll also be working with subject matter experts to expand and refine our analyses. And as I've mentioned multiple times throughout this presentation, CCAR is a stakeholder-driven project. So if you have any feedback for us, we are always welcome. We always welcome it and look forward to hearing from you. So thank you.
Thank you for that, Cheryl. We welcome questions and feedback. Well, I'll bite. I always have questions and feedback. Yeah, like one of the reasons I wanted to invite you is just, I mean, the wealth of information that is being produced out of this program, and the continuous data is something that I'm really interested in. A lot of the stuff that was ported over from the NERS program that you guys have adopted was stuff that I was playing around with when I was doing my postdoc, like over 10 years ago. So it's cool to see that. But what has really been amazing watching this progress is how the data that you're producing, the continuous data, has been integrated into the CDMO from NERS, which is the NERS national infrastructure for hosting their continuous data. And I'm just curious if you could comment on like how seamless that was or not seamless, or what challenges you've had doing that, because we have some continuous monitoring data in Tampa Bay that's hosted on a separate framework that I think I talked to you about a little bit at the tech transfer meeting. But how was your experience getting that into the CDMO?
So it was really, really simple, honestly. They have lots of great tools. Since we're using YSI instruments, we were able to utilize the CDMO non-swamp data portal to do the initial review of our data. And then once we get that file back from them, we utilize their macros to do the secondary QA/QC. And from there, we're following very similar protocols to what they use, with a few modifications to ensure that we're meeting Florida's state SOPs. So some of our requirements are a little more stringent than theirs. And then Jeremy created a separate portal for us, but it follows basically the same format, and the exports are again in the same format. So we've been able to utilize that data together very easily. And I know that you've worked with Dwayne and Melissa and Jeremy, and they're just absolutely amazing people to work with. So that doesn't hurt.
Yeah. Okay, I could have another question, but Lindsay has her hand up, so I'll let her go.
Yeah, okay. I don't live in Florida, so I'm thinking about this from a completely different perspective, I suppose. But I think the thing that I see as a commonality among other data intensive projects I've worked on is the heavy lift that you've done to harmonize the data across the different programs. The mapping step that you talked about is something I do quite frequently in my work, and it sounds like a simple step, but it is a really heavy lift to actually create the mapping across the different systems. I guess I'm curious if you can talk more about that and like what the, I don't know, like the maintenance is for it, because I think there are a lot of really cool tools that are built on the effort that went into that harmonization. Yeah, I'm just curious about that.
Yeah, so since we have a drag and drop system, because the database was created based on what the data providers wanted. I called it originally the list of demands. It seemed pretty unattainable, and we've actually accomplished all of them, which is amazing. But they wanted to just be able to provide their data in whatever crazy format it was collected in. And we get lots of crazy formats. And so we have data integration procedures for every single program, and those are available on it. So it goes through how each of the columns of information are pulled in. And then, as you said, we require them to have coordinates for each of the monitoring locations. And then those are mapped. So we have to the University of South Florida does that initial data integration, and then quarterly our team goes through and quality checks that data. And we have Tyler's created an amazing script for us that creates these QA/QC reports, and we are able to go through each of them. We go through the maps to make sure you saw in the distribution maps, I visually go through and check a certain number of them each quarter to make sure that there's no dots showing up in like other hemispheres, because sometimes they're less extreme, but we've had lots of people who are traveling very far for their monitoring efforts. And then that requires reaching back out, getting all of those fixed, re-uploading. So it is extremely labor intensive. We do update the whole period of record every time. So I think I mentioned in the presentation, like if you were doing this manually, if we didn't have all of that scripted in for those errors that we hit last time, we would just keep facing these issues over and over again. I mean, I know we've all tried to like combine 2 or 3 data sets on our desktop, and just how horrible that is. We have 157 programs contributing to CCAR that we're standardizing 67 parameters for, and there's, let me see, pull up the dashboard. Yeah, almost 530,000 sampling, unique sampling locations that are included. So, and the water quality stuff is really cool. But honestly, some of the stuff we've been doing, like with the oyster mapping and monitoring, is even cooler. Because we've been utilizing FWC's Oyster Beds of Florida map, and we've created, Marcus, so yeah, you've used that. So every time they create a new map, they're just using the newest mapping effort, and the IDs that they have for each of those reefs changes every single time. And so again, Tyler created a way to look at all of those layers, and we've created a standardized reef ID for all of those reefs that we're able to match to the data, so we can tell if different programs are monitoring the same reefs. And so that's led to some really, really cool monitoring tools that we've rolled out. So I think I got way off subject, Lindsay. I'm sorry. I get really excited.
No, yeah, I love it.
Did I answer your question somewhere in there? Yeah, Alex.
There's a lot of cool stuff. Thanks for showing this. I was like kind of familiar with CCAR, had an idea what it was, but didn't realize it had this much depth to it. So really awesome. I know at the county, we provide some seagrass data. I'm not on that side, but work with the people that do. And I know you were just talking about the QC reports. That's kind of the main thing I do with the county, take all of our data and combine it and make these QC reports. And I see a lot of repeat errors that people are making, try to get them to stop doing it. But do you see a lot of repeat things from data providers, or is it kind of all over the place? Or like what would be the biggest issues that people could fix that would make your life easier in terms of doing manual QC?
And it really varies. I think originally we've also created a standardized species list that links back to authorized sources. So when we first started doing this, I think Steve and I spent all of our time, I'm not even gonna say 90%, I think all of our time was dedicated to going through and figuring out what all of these were, because of the trying to match acronyms, misspellings, outdated taxonomics. So like all of that information is just really, really hard because people aren't consistent in how they're even entering their own data. But we have created, and if you're really interested, if we have time at the end, I can share my screen again. But we actually just in the last 6 months created a program editor dashboard on. So when you log in as a program editor, you can now see all of your data that's flagged. And so that's if it's outside of expected values, if it's outside of thresholds. And then we also run the quantile values on the, screwing that up. So we look at the upper and lower quantile values for all of the data in CCAR for each of the parameters. And if your data falls outside of those quantiles, then we flag it as well, because there's a lot of data in here. If you're not falling in there, it's probably not right. And that's resulted in a lot of things being fixed. But I think that's probably probably the most common thing that the data providers are thanking us for, is that QA QC that we're doing on their data and allowing them to fix that, which is good. It's kind of sad that their data is not always great before it comes to us, but to be able to provide that and know that, our data across Florida is being improved because of these efforts is also pretty rewarding.
Well, I'm sure we could carry this conversation for a while. But
I'll
before we move on to Lindsay, it's very clear that you have a ton of data, and I just gold star A+ for your commitment to making it as open as possible and following, set standards for ensuring the quality of that information is appropriate for use by others. So I look forward to seeing how this program evolves and how the data will be used by others moving forward. So appreciate that, Cheryl.
Thank you. And again, any suggestions, send them our way.
Will do. Okay, well, let's move on to Lindsay. You're in California, so I know it's very early.
Oh,
Appreciate.
I'm not in California. I'm in Wisconsin, but Kimmy is in California. Yeah, it's not so bad.
Well, let's see. It's still early in Wisconsin, right?
Yeah.
Either way, appreciate you being here. We like to bring in outside voices as much as possible too. So I think you've got some good perspectives you can share with the group. I don't know, Alex, if you wanted to say anything as well before Lindsay kicks off.
No, we had a good conversation when we met at the Modern Conference, and I touched on some of this a bit. So, I think people will get a good idea for some of these skills.
All right. Well, take it away, Lindsay. Thanks for being here.
Yeah, thanks. Yeah, that's when you came up to my neck of the woods, Alex, in Wisconsin. So happy to be here. I love this discussion because I'm a huge advocate for open science and I would say reproducibility techniques more generally. So happy to have a discussion after this. I will attempt to be as brief as possible, but we'll see how that goes. So my name is Lindsay Platt. I'm an environmental data scientist and currently the lead of operations for QUASI, which is the Consortium of Universities for the Advancement of Hydrologic Science Incorporated. We are a small nonprofit. We have about 18 employees whose mission is to support water research in the water research community, which I will get into in a little bit. So you make these slides before you know what the other person is talking about. And so I just want to point out, we kind of begin all of our talks about QUASI's role by directly addressing this kind of disconnect in the water research community where we have a lot of different groups generating data, a lot of academic groups, state agencies, local, other nonprofits, and there's not as much integration across those systems. So water science isn't able to be leveraged in the way that it really could be because we are fragmented. Water science is generally under-resourced and disconnected. I would say what Cheryl just talked about is a great example of the opposite of that, which is kind of what we're all hoping to move towards. So that's amazing. And QUASI's role is is to build towards more of that kind of integrated science community that has connections with other researchers and decision makers, has infrastructure and really the expertise to kind of bring the data and the information from the different research that's happening, the different science that's happening together. So that's what our role is. We are facing a lot of water challenges, drought, flood, groundwater depletion, water quality issues, access to clean water, and those kinds of things don't respect the disciplinary boundaries that we in the water science community often follow ourselves when we're doing our research. And so this image is kind of how Kwasi likes to describe our role in the water science community. This is our vision of a thriving community that gathers across those institutional or disciplinary boundaries that we've created so that we can collaborate and share data and build skills and just generally work on problems that are too large or complex for just one discipline or organization to solve. And the blue overlay here is what Kwasi is contributing to it. So we aren't the whole picture of the water science community. We aren't actually doing the science. We are building the conditions for the science to be done through infrastructure, training, and community convening. And one good example of this is our kind of flagship data repository, which is called HydroShare. It's a community-built tool that we have adopted and extended as a solution for the whole water science community. So HydroShare is a water data platform, and we took over operations and maintenance of it in 2018, but it was built out of a collaboration of 14 different institutions, including leadership from one of Kwasi's founding member universities, Utah State University. And it's widely leveraged by researchers and grantees for data collaboration and publication. So HydroShare has a number of different capabilities, and within it, a researcher can upload data really of any file type, collaborate on a model with colleagues, maybe across different institutions, publish their data set with a citable DOI or digital object identifier that is often needed to satisfy open access requirements by different journals and by funders. And then it also has the ability to launch and run code. So let's play this little video while I'm talking. You can execute, modify, and share code workflows alongside your data in the platform without ever needing to configure a local setup. So this is, again, something that really helps in the open science world. Is we all have this challenge of, oh, I have this version of a package. So my workflow doesn't work in the same way that yours does. But in this situation, you're launching into an environment that is pre-configured. And so you can end up with the same results as somebody else and without the burden of that setup. So this is just a video showing actually our code downloading USGS data in a Python notebook. Okay, so all of those capabilities in HydroShare can really be linked back to important open science ideas like FAIR, which I think I've seen in your documentation online for your group, but FAIR is the idea of the data you're producing being findable, accessible, interoperable, and reusable. And then the other kind of open science principle that HydroShare enables is the idea of reproducibility, which is about the process to get to that data. So FAIR is the kind of end product, and reproducibility is all about, okay, can you recreate that end product? And it is, I think of reproducibility and I think of the kind of basic idea of how science operates, which is you do your science, you publish it, and somebody else can take the same methods you described with the same data, and they should end up with the same results. And I want to focus on this idea, and I I do so a lot because reproducibility is such an important part of open science, because we're always wanting to build on the research and findings of others to move science forward. But this is getting more complex to actually do. It's not as simple as, oh, I'll just apply the same methods to the same data, because we are often working with much bigger data than we were before. Our analyses are getting more and more complex. They're usually like lots of code behind our analyses that we're doing. We're bringing together a lot of different data sets, and just generally the teams that are working on the science are larger in number and interdisciplinary. So it's a challenging picture now. And I like to illustrate the kind of concept of reproducibility with a bit of an example that I hope, well, not hope, I assume many of you have experienced before, which is you have just finished up work on some project that required data analysis of some sensor data. You've packaged that up, you've put it aside, and you've moved on to the next thing. And then you receive a message from a colleague. Abner Bogan is a fellow quasi scientist. And you get this message from them that's like, oh, I know that you were done, but actually we had to go back and correct some data. We need to redo what we've done. When I get a message like this, kind of before really injecting data reproducibility practices into my workflows, it kind of stops me in my tracks, and is, a frustrating thing to receive. And so you have to think back through all of the different steps of your analysis that's impacted by this one sensor malfunction and the corrected data. So you're like, okay, maybe I did some stuff in code. I did some transformations or joining of data in Excel somewhere. I'll have to go figure out what I had done for that. And maybe I even asked a colleague to do some portion of this work because they had a tool I didn't have access to. And so I'll have to reach out to them, make sure they have time to actually devote to it and get that done. It's hard to really like isolate and pinpoint redoing the steps that are only impacted by this one potential sensor and the probably, small number of data points that were actually corrected. So really, after thinking all that through, you have to say, okay, I'm going to start back from the beginning here and just rerun everything. It's not the most efficient way to do it, but I don't know what might be impacted from this one change. And so I use this example because I think there's reproducibility in terms of, okay, I finished my project and I can publish the results and the methods and everything, and that part is reproducible. But I did it all at the end. I made it possible to describe and do that at the end of my project. But I like to expand the definition of reproducibility because it's almost more important to be able to reproduce things throughout a project kind of continuously. So you can be making decisions and tweaks along the way and have confidence that the changes that you're making to, maybe a threshold that you picked or corrected data or something are propagated correctly throughout your entire workflow for your project. So this is the kind of expanded definition I like to think about. And there are a number of ways to achieve reproducibility. And they're not all, having the most technical skill sets to build something. I like to think about this kind of pyramid of tiers of skills that support reproducibility practices. So everyone can support reproducibility by having good documentation of their steps kind of right from the beginning. And then as your project becomes more data intensive, you might want to consider adding some additional skills that are more technical. So maybe you look to track code changes through version control using GitHub as like a next step. And then maybe eventually if you have a lot of data and it's very complex, you're turning towards some kind of automated tooling by building out like full data pipelines. So to me, it's not like an all or nothing. You may never need that like top tier building automated data pipelines, but it's good to know that that is a very reproducible state, but it does take a lot of time and energy to get there. But you can start with simple documentation. And the reason why I think I don't advocate for everyone jumping to the top tier, always building automated data pipelines is one, you don't want to use a tool that's too much for something that you are doing. Sometimes you don't need an automated data pipeline, but also there are very real barriers to building that kind of skill, which is time. We're all time limited. And in a lot of cases, the skills that go into reproducibility, and I would say open science generally, so this is good that you all have this committee and are interested in this topic, but generally they don't carry the same weight or prestige as other scientific practices. So it's harder to find the time to actually build the skills for them. So I like to just highlight 3 things that really don't require a huge investment in any new fancy skills. There's something that you can do kind of right now to improve the reproducibility and move more towards open science with kind of any project that you're doing. So the first that I like to think about is just project file organization, which seems like a silly, mundane topic, but it takes no technical skill. It just takes some time and thought to, as a project group, care a little bit about how files are organized and named, because it's amazing how much of a difference having a naming convention can make on the readability and usability of a project by anybody. You don't have to go through and open 6 different files to figure out which one has the information that you're looking for, because you've named it in a way that's really logical and consistent. The second one is to, and I was happy Cheryl talked about this earlier, and I think Marcus, you may have touched on this too, this idea of machine readability, which is that, I think I also saw it maybe online in your documentation. Excel is great, but Excel allows users to kind of do whatever they would like. I would say a lot of times as an Excel user, when we're in control of building a data set, we are focused on improving the human readability of that data set by merging cells or having color or having multiple tables in the same sheet. What's challenging is when that gets later on, it's harder to maintain. It's not easily read in by a coding language or used in some way that, Cheryl's team's using, where they're integrating all these different data sets. It makes it harder for long-term use. So when you're in control, considering the end state and use of the data and trying to create things that are machine readable goes a long way. And then the last thing is just documentation throughout your project. I think a lot of us think about documenting code and processes and like data and metadata for the publication or the final state when we're going to share it out with other people. But again, I think reproducibility really comes down to your ability to do things too. And so future you, which could mean you next week when you pick this project back up, you in a year from now when you're like, oh, I did this in a previous project, I don't want to have to recreate that. How did I do it? That is a really important part of open science and reproducibility, the idea of future you. So I would encourage documentation, even if you aren't going to share it with anybody else. Okay, and then I did just briefly want to touch on what investments there might be to get to that top tier of reproducibility. Yeah, just lightly, just to give you a little bit of like a nugget, a seed. So that kind of top tier touches on this idea of dependency tracking through what's called data pipelines. So it's a technique where the different steps in a data workflow are connected and linked. And so when one thing changes, it causes a kind of ripple effect of downstream updates that are automatically run. And if there are no noticed changes at all, the workflow just kind of skips over anything that isn't impacted by it. So it is an advanced technique. I use an R package called targets to do this. I have a blog post online with my colleague Abner all about how to get started with targets. We also include a 90-minute workshop recording of us teaching targets. It is one of those like advanced techniques to do data reproducibility, and it is a skill you would have to invest in, but targets I think is the most user-friendly way to do it. But there are other options. SnakeMake is a Python version, and then there are language agnostic tools as well. The final thing I wanted to just say, especially it sounds like in this room, maybe there are people that are in some leadership roles, faculty members as well. And I think this community is a great example already of the cultural support needed to move the water science community generally towards these practices. But maybe a more specific example is everyone's sharing these tools, which is a really great step, but sometimes there's some even simpler ways to support people, which is just providing some peer reviews on code that they've written. It can even be as simple as like sharing a project folder and trying to see if the naming conventions you've chosen make sense. There are a lot of simple stepping stones ahead of like building out full tools that can be helpful to build confidence and share knowledge that give people the right tools to build their open science skills. And then the last thing I will say is hiring out expertise that focuses on the data integrity in your project or team is really critical. I think sometimes we take it for granted, and the like open science practices in a project can kind of fall victim to like the tragedy of the commons, where everyone's like, of course it's important. We'll definitely do open science as part of this. But if you don't have somebody who's kind of on point and responsible for carrying the data and open science torch, yeah, it may not happen or get kind of lost in the shuffle. So always an advocate for that. Okay, I'm realizing what time it is. I guess we won't have as much time. I talked slower, but yeah, I always like talking about these things. It's really great to see a whole group committed to this. Marcus, I see your comment about abusing your data with Excel. Yeah, can be a challenge. Yeah, I'd love to hear if this resonated with anyone, or yeah, what other challenges you have.
Thanks, Lindsay. It definitely resonated with me. I feel like there's like almost a one-to-one agreement between like your thinking about it and how, we have our data management SOP where we've tried to outline our way of thinking about it as well. I can ask a question, but I will defer to the room if there's anything immediately pressing.
This isn't a question, but you're framing around, writing code for future you. It's hard.
Yeah, I had a colleague once say, like, future you is the worst collaborator because they won't answer emails. And that has stuck with me for years.
That's right. Yeah, it's amazing the things that I take for granted that I'll remember.
Yeah, yeah.
You can be your own worst enemy.
Mhm.
Yeah, that's a point that I've harped on in the past too, when I've done like open science trainings or just trying to talk about the value of it to people. Like, yeah, these things are good when you're in a large collaborative group and you could speak about these tools in that way of, facilitating collaboration. But like everything that I try to do in my job, I put it up on GitHub and like 99% of it, nobody will ever see it. but it has like for me, future me has been like the primary audience. Like I can pick up something that I worked on 3 years ago, and most of the time it will run out of the box where, it was something that I did 3 years ago, where in the past, had I not been using these workflows, it would have been almost impossible to try to piece the breadcrumbs together. So future you is oftentimes the more practical audience, I think, for adopting these tools.
Yeah. Yeah, I think too, not every workflow can be automated. There's oftentimes some kind of manual step like, oh, this particular data set, there's not an API for, so you have to go manually download it, but just explicitly writing where that data came from, like in the code itself that you might have, is like always a reminder to me, like, oh yeah, I went and I got it. Here's how I did it. It's so critical.
I literally did that this morning. I created a repo for something, and I linked the directory to one of our internal drives, and I was like, it's not reproducible, but that was the breadcrumb for future me.
Yeah.
Where the hell did this come from?
Yeah. Breadcrumb is, a great term for that, for sure.
Well, go ahead,
I
Steven.
I did think of a question, Lindsay. When you were mentioning the DOIs being, um, often required for publication and for funding requirements, I was wondering if you have ever encountered um, people contributing to Kawasi HydroShare who have, like an ongoing data program. Like, how would you assign a DOI to somebody who's
Yeah.
like an active water quality monitoring program, for instance?
Yeah. We see it used in a number of different ways. Getting a DOI and publishing your data is just one of the options. But you can have public data that doesn't have a DOI on there as well. And so you can create, we call them resources. I've seen people do this for, like a group or a site. They create a resource and then you can kind of have subsets or like sub resources linked under it that kind of like group them together. But they never have to make it to the published state. They can be just available for others to find and download without ever getting that DOI. The DOI is one of the options that you have. You can also
Okay.
keep it completely private on there too. But with unpublished data, we do have a like 20 gigabyte limit per user account, unless there's like a special agreement worked out. Once you
Okay.
click publish, we take on the storage quota and commit as part of that to it's like persistence through all time.
So they don't, the DOI is kind of, it like, I don't know what's the word, like fossilizes that page essentially. Like it's no longer updated.
Correct. Yeah. Some people will later find changes and they'll like make a version 2 that has a separate DOI. But that step is often the requirement a lot of people have when they're, they have like a journal publication coming out and they require you, a lot of journals now require you to have your data available with a DOI. And so, yeah, you're kind of freezing it in time to say like this is that data that's linkable and persistent.
Interesting. Okay. Thank you.
Yeah, we had that same issue. We have a data set that we archive every year, and we were using a not HydroShare, but on Data One through KNB, and I had the same problem where I was like, well, we're updating this every year, but I want to keep the same DOI, and that's not really like true to what a DOI should be because you're literally changing what the database is, even though you're just adding on to it. And I kind of went back and forth with the maintainers of that. And I was like, please, can I just have a one DOI? So like when people cite it, it'll go to like the most updated version. And that's kind of like a divergence of how one should think about what a DOI is. But Yeah, I think it comes down to like a philosophical perception of what that identifier should represent. But I think more often than not, it should be, that snapshot of what something is at any given point in time. So that just a side about that.
Yeah. That is like the reproducibility factor too,
Yeah.
is that they can always go back to that exact same version of the data. Because that's sometimes the challenge with downloading data from, like I think about the water quality portal. If I download data today and then I download data next week, not only are there new records, but some of the records that I did download could be slightly different. And so, yeah, having some way to say like, this is the exact snapshot of the data that I use is helpful. But there are use cases where you are amending the data through time also. I just would say like, yeah, you could have it available publicly without actually putting a DOI on it.
Yeah. You don't have to check all the boxes when doing open science. And I like the way you framed it as like there's very simple things you could do that could help in many ways. And you don't have to do all the things because it could be a lot to try to do that. And there's certain cases where it benefits you to try to do that, and other cases where it's just not practical. So, well, thank you, Lindsay, for that. That's amazing background and the work that you're doing. A lot of applicability to what we're trying to do here. So I appreciate you sharing that. We are at time, so I'll just close out. Our next meeting is December, so 6 months from now. Have a good rest of your field season. The only other thing I wanted to bring up that you can check out on your own time is our constantly evolving AI policy slash guidance slash way of thinking around it. I have a link in there. We recently updated it. Probably not the last time, definitely not the last time. But we adopted a general policy or framework around it like 2 years ago, and then looking at it recently, we're like, this is horribly out of date already. So we updated it. And just, I know a lot of organizations are thinking about how to use AI and responsibly, and maybe crafting similar statements to sort of put guidance and guardrails around using it. So I'm sharing that for the broader group. But if your organization has guidance, please feel free to share it with us. Having consensus on these things, especially in similar use cases around environmental management or data science, would be appreciated. So have a look at that. Alex, any closing remarks?
No, I agree with the AI. I think it's it seems like something that needs to be updated at least once a month these days. New models always coming out. But yeah, thanks everybody. Thanks Lindsay and Cheryl for presenting. Really appreciate it. And yeah, looking forward to seeing everybody in 6 months.
Thank you.
Hey, thanks everybody. Thanks Lindsay. Thanks Cheryl. We'll see you next time.
Thank you.
Bye.
Thanks, everyone.